Okay, I guess it's time. Hey everyone, glad you're here. We are Slava, that's me.
And Anton, that's me.
We are from Monoid AI Safety Hub, and what we're doing today, um, hmm, my slides are not working. Yep. What we're doing today is sharing a few ideas from the technical AI safety course we are working on. It's a course for people who are past I've heard of AI safety and ready to move into I'm starting to do my first actual research. And alongside concrete research agendas, the course also includes some high-level frames, the kind that help clarify what kinds of questions are worth asking. Some of these frames help with choosing a direction for applied research. Others help with figuring out how to formulate a new research problem in the first place. And the goal is to support early researchers in answering something like, okay, I want to do useful AI safety research, but what exactly am I trying to do here and why does it matter? Today, we're sharing three such ideas: how to operationalize the concept of a goal in AI and what we might call an Aimslot. Second, what thinking in terms of configuration and outcome space looks like, and what unipotency and pluripotency means. And the third, how all of this ties back to concrete safety problems. And what we want to know is kind of, are these ideas actually useful? Do we kind of miss something important? We plan to have three blocks of 30 minutes. Each starts with a short talk and then opens up for a discussion. But our talks, at least mine, appear to be a bit longer. So we'll probably squeeze the third part or maybe cut it off. But let's just move forward, go fast and break things. All right, one sentence version. What we are going to do, we'll throw out a few ideas and ask what you think. The ideas are meant to feel kind of obvious and kind of true, as in all models are wrong, some are useful. And the real question is, do they help reveal something new or help resolve uncertainties that were hard to pin down before? And the kind of underlying question is, do you see we are wrong in something or missing something important? So let's go. First talk. And this first part isn't really one idea, it's more of three related points. Here's the list.
Something happened to the video, I think.
Okay, let me try. Yep, I think it's working now.
I'm not sure I am seeing the presentation.
Let me try. There you go. Okay, talk one. Thank you very much. So the first kind of part of the first talk is goal as a pattern defined on outcomes. The second, why it is always about the ontology of the observer. And the third, the concept of Aimslots and kind of natural aimability. So, point A. Not working yet? Hmm. Yeah. AI goal as pattern defined on outcomes. Nate Suarez says that To solve alignment to make a safe AI means to build something with a goal slot and to establish a goal within this slot. So it kind of becomes a question, how can we tell what the goal of an AI will be before we build it? All right. Firstly, we think it's useful to distinguish at least kind of three things. I love number three. Loss reward function we use to train the system, kind of internal representation of a goal, like an invariant over desirable world states represented in the model, if such representation exists. And the third is the pattern defined on outcomes, the sort of teleological goal we would assign to a system based on its behavior. There is a lesser post. Reward is not the optimization target. It unpacks why the first one can't be directly used to predict behavior on the system we train without additional assumptions. But mostly it's a tangent for this talk, so I would just recommend you consider reading it. And the take I make here is for safety, for AI safety, it's necessary and maybe even sufficient to predict, control, and specify the third thing, the outcome pattern. That is what determines what we actually want to know when doing AI safety. Of course, reward loss is necessary to build systems. Internal representation of goals might matter for moral reasoning or curiosity, or might be not applicable to the system you are building at all. But it's the third one, the thing visible from the outside, from third person's perspective. It is what we are talking about when we say to set a goal of an AI in terms of AI safety. All right, all of that in one sentence. What matters most is not mixing different meanings of goal of AI, at least not within the same conversation or the same sentence. The reward loss it was trained on, the internal representation of kind of behavioral drives, what it might think it wants, and the pattern on outcomes, what the system actually ends up causing, ends up doing. And for applied AI safety research, it's probably makes sense to prioritize the third one, the pattern on outcomes. Point B, why goals need ontologies? Well, you can't assign a goal as a pattern defined on outcomes to a system in vacuum. It's not just because of no-French theorem. It's the one that says that all algorithms perform equally badly across all possible problems on average, but there is also something John Wainsworth and Richard Gore talk about, the idea of ontology. It's the thing that even lets us say what counts as outcome one and outcome two. Let me kind of give you several examples. Okay, here's the obvious part, the part people say a lot, like if we say deception is bad and we want to prevent AI deception, the system, our AI system, needs some way of knowing what deception is. If we want to maximize diamonds, we need to define diamonds. But what I think kind of gets missed more often is this. Once it becomes possible to define what diamonds are, most of the hard work of building an ontology is already done. Yeah, it's not easy to carve out chunks of reality or to cut reality at the joints, as the Marie folks say, but it's kind of really hard to come up with an approach that actually makes that cutting work in practice. It's hard to produce even somewhat formal mathematical model, one where we can make predictions and where the AI system looks like it's acting in accordance with the concepts this mathematical model is grounded in. Ontology defines which outcomes are distinguishable, and that defines which patterns on outcomes can even be assigned. And this matters, especially in mechanistic interpretability, and that's actually isn't a brand new idea. No, it shows up on Less Wrong and Alignment Forum. It's also considered in some interpretability or agent foundations work. Um, but kind of in the second talk, Anton will introduce something a bit more mm, brand new, a bit more specific for us. And that would be the concept that directly addresses this issue of different ontologies. And if we have the third talk, we'll look at some of the applied implications we assume. So let's cover up a bit. Point A was we can think of AI's goal as a pattern defined on outcomes. Point B, to even set a pattern on outcomes, there has to be kind of an ontology, some translation from what we, the designers, call outcome one to what the model can represent and act on. Now, let's go to point C. Yeah. Thanks. What does it mean to make a system aimable? If we go back to the same quote of Nate Soros, he speaks about a goal slot, something that should stay stable under various operation pressures. We tend to say aim slot, not goal slot. Actually, no difference, but that kind of helps us avoid anthropomorphic confusion, and it helps keep the distinction between goal as internal representations and goal as outcome patterns kind of clear. So here's the take. Some systems that we as humanity build, they come with an explicit aim slot, and others don't. And the intuition we are working with here is think of two systems, kind of a stamp and a printer. A stamp produces fixed outputs. Each time you press it, you get the same imprint. If you want a different outcome, you have to physically alter the device. Carve a kind of new stamp, rebuild it, reassemble parts. A printer, on the other hand, has an explicit input channel. You don't need to open it up to change what it prints. You just send a new document. And that's what we mean by an aim slot. In stamp-like systems, Goals are kind of hard-coded into the architecture of the system. In printer-like systems, there is a clear interface for setting or adjusting the current aim. And when we say make the system aimable, what we actually mean is build an interface that lets us influence some internal parameters, and changing that parameters causes kind of downstream changes in the system, and those changes show up at the level of behavior, producing actions that lead to outcomes we want and kind of avoiding ones we don't. So, in short, what does it mean to make a system aimable? What we want is a reliable interface for specifying and adjusting systems' behavior. And here is a strong claim. By default, systems aren't like this, especially the ones trained via gradient descent. Most ML systems today are stamp-like. If we want them to be aimable, we need to either build them like printers or figure out how to retrofit this interface in. So the obvious question is kind of, can we add this interface after the system is built? And if so, what kind of understanding would that require? We'll touch on our answer to that in part 2, but for now, let's wrap up and go to discussion. So here are 3 ideas from this talk. We can think of a goal as a pattern defined on outcomes. To set a pattern on outcomes, we need an ontology, something that maps our concepts to the models. And the third one, making a system aimable means building a reliable behavioral interface, that mapping. And that's not a default property. We don't have naturally aimable systems if we create system using machine learning. Okay, now we are ready to go for discussion. We have prepared a few prompts. You can see them on the slide, but let's start with something better. If anything here sparkled a thought, a question, an objection, a comment, now it's time. Go ahead. Okay, then let's try to go to the discussion part and try to touch the first prompt. Thank you, Roland. We have these 3 definitions of AI goal. So what do you think of this definition, and do you think people, which of them do you think people confuse most often? Maybe a more kind of explicit question about might it be that internal representation of a goal be something more important or more useful for AI safety than the pattern on outcomes? How do you think? Not really a vivid discussion here. Okay.
So, sorry,
um,
sorry. Hello.
Hi,
I
Norman.
kind of missed the previous 2 minutes because I went to the bathroom. So, can I ask a question about? Uh,
Sure, please go ahead.
yeah, yeah. I'm. Uh. So I guess my when I heard about the like the interface metaphor, uh, or is it the printer metaphor and the interface? I think it's a nice metaphor, but I do have a question of like where does where do biological systems or humans in particular place in on this dichotomy, because it's like we humans are kind of amiable to the extent that we could educate people, but it's not like we have a it's not like education provides us with an interface for the person's minds mind or behavior. It's but it's more like uh, you could make a reasonable attempt at educating him or her, but it still ultimately depends on whether uh, he buys that, like he's convinced. I guess that would be a general issue if you're constructing agents, and and I wonder like what how, so is this like a third form apart from printers or stamps, or do you could you like accommodate this in your terminology?
Well, I think that applying concepts from machine learning to humans, it's always kind of, I would be careful with that because when we speak about machine learning, it's one thing, and when we speak about humans, it's always ethics involved. But I think the concepts itself are applicable. And anyway, like this, being a stamp like or being a printer like, it's actually a scale, not a trigger. And I think humans are kind of shifted to the printer on this scale. We have kind of languages, as Anton wrote in the chart. And also, we have culture. It's kind of specific forms of the input we are ready to kind of accept to change our behavior. Like one forms of asking, please stop, I don't know, eating my food. It's kind of okay. And the other form is, go away from here, it's my food, are a bit less okay, but still acceptable. And some forms, which I would not pronounce right now here, count as unacceptable and probably will not change your behavior. So we
How
can.
sorry, yes, I get it. In what sense do would you say that humans the language is a effective interface, uh, while for LLMs it is not? Because from what you're saying, it seems that you're saying that machine learning systems we don't have this interface yet. But if language is the interface you're proposing, then uh, yeah, how about LLMs?
Mhm. I think it's some kind of difference between what is necessary and what is sufficient. Like it's necessary to use language this exact person understand, and just the same, it's necessary to use kind of input LLM can um, do something after them. But it's not sufficient. Like if we know the language, it's not guaranteed that we can um, talk person to something. So, as I mentioned, culture is one more step. If we understand a culture this person is kind of used to and agrees to, it's also kind of increases the chances, but it's also not sufficient. And I don't think we could have in human society sufficient uh, ways of changing humans' behavior because we kind of value our freedom. Evolutionary, we kind of evolved to resist control, and also culturally, it's something we value. Simon raised his hand. Go ahead, please.
Yep. I just wanted to say that I mean, it seems to me that humans are a little bit more akin to the stamps in your analogy because, um, well, it seems like our end goals don't change. And I thought what you were kind of getting at is that with AIs, their end goals don't change. They're static, because there's value lock-in. Um, and the stamp is kind of like that. It can only really do one thing, or it only, if you want to say, the stamp has a goal. Its only goal is to stamp that one shape or whatever, you know. But anyways, it seems like humans are also. It seems like our end goals stay the same. Our terminal goals, our instrumental goals may change as we learn new things and stuff like that. And communication helps us learn stuff and helps us develop our ideas, but uh, we still care about the same things. Our values don't change. Does that make sense? So
Yeah,
yeah, I would just.
sure. Also, what I should have told is that mm, I do think that being stamp-like and being printer-like is a scale, and then like it depends on you. Uh, where do you think humans are on this scale and LMs are on this scale? I'm a bit, personally me, a bit more optimistic, and I think we're closer to a printer like, but maybe I think so because it's kind of part of wishful thinking, uh, because I'm trying to find a way to kind of retrofit an interface into LLM so it would be aimable. I'm not sure, and of course there can be other points of views.
Do you feel like your end goals ever change, or do you feel like they're static?
Yeah, I think that this part might be really different among people, and for me, yeah, they did a lot dramatically during like my life.
Mm-hmm.
I think people are really different on this regard.
Right. I guess also one other thing. This is kind of a little bit of a separate topic, although it is certainly related. I was wondering, you mentioned a less wrong post, which was like talking about how the reward isn't the goal, and so I was wondering if that also applies to human. Like, if joy is a reward, does that make joy not the goal? And if so, why? Um, yeah.
Um, it's okay. I should finish my talk, but give me 1 minute. Um, this is about the function that was used to train a system being different for the function we can say now the system is kind of optimizing for. Literally about the difference between the reward function and the kind of pattern on outcomes that can be observed in RL agent behavior. And actually, I think it's you can apply this as a metaphor to human and get that IGF. I mean, all this stuff for spread your genes is not what we are internally or observed from our current behavior in 21st century, what we are optimizing for, but somewhat it's we are here only from being ancestors of those who spread their genes most efficiently. I think it's this kind of difference.
Right. Um. So, I don't know. I just think like if you had some and if you had some system which you're training it using some sort of reward model, if you like as you continue to train it, I mean it just seems kind of like a little bit dumb for the system to not be able to be like, okay, I'm currently using strategy A to get rewards, and this is what I've been trained to. This is the strategy I've been trained to use. Why not use strategy B to get even more rewards? It just seems like, I mean, you've been training it because you want its terminal goal to be A, but I mean, I don't know. It just seems like it's still instrumental to getting more reward. That's what the AI values. The value of the AI is the reward, not the intermediate goals to getting it. And I might just need to read the Less Wrong post. I mean, this is something I've been confused on for a while, if I'm being honest.
Sorry,
I think
I guess I kind of have a different interpretation for what Slava said. Uh, it's is it like is your picture more like the system is following the reward signal ultimately, as Simon says, but viewing from our like human ontology, which we're not able to completely embed into the system as of now, we see a different goal. Like we see a certain pattern of outcomes that's not encapsulated by the reward function, but we would classify as a goal, and that's the other goal that Slava is talking about. Yeah, maybe it's just my own interpretation. So yeah, what do you guys think of this?
um, I mostly agree that we have this what we trained it on, this reward function that we like encoded, literally encoded it, and then we ran the simulation, trained the system. Then it might be that inside the system, uh, it appeared to kind of uh, to be some kind of internal representation, kind of reflective intelligence, being aware of its own goals or values or drives, or it might not be the case. But anyway, from outside view, as Norman said, we can look at the behavior and kind of prescribe from our ontology what is the goal of the system. And yeah, it's different. But anyway, I took 5 minutes from Anton's talk time. Shame on me. Anton, please go ahead, talk to, and then we'll continue the discussion if you don't mind.
Oh, I don't mind at all. All right, let me figure out how to present. First, do that. I'm doing that, and I'm doing this. And it should have come out. All right, everyone seeing the presentation? Right.
Yeah, that's great.
Mm, right. So let me move on to, well, the name of the talk that you can clearly see at the slide. So, first of all, clickbaits. What is the aim at which a power station is pointed? Can it be reconfigured to point differently? What about the aim of a hanger, of a rock, of a laptop, of financial markets construed broadly, of a chat GPT? Mm, the aim here being what my esteemed colleague described as pattern on outcomes specifically. Uh, now, mm, first distinction I want to draw is that some systems have basically one aim they can be pointed at and, I don't know, manifest well, perform well. There's basically one succinctly described set of outcomes that can even happen when the system operates as normal. Like, take a power station. It is set to output approximately electric power within a given range of voltages, amperages, other characteristics. It has some configuration. It has, metaphorically speaking, levers, hinges, movable blocks. I don't know, mm, some computer code describing how it all of that is to move, reacting to conditions. So we can use all of these tools to change some things about its outcome. We probably can, I don't know, raise the outcome to within its operational bounds. We can lower it to some, again, bounds, possibly to zero. We can theoretically make it burn itself out. What we cannot do in any way using these control levers is to make it filter water or cook food or immanentize the eschaton. Likewise, with a hanger, we can probably configure the relative angles of the hook and the triangle part of the hanger. It's pretty hard to make hanger do anything but hang. On the other hand, consider a laptop. It will show movies, it will trade stocks, it can help with drawing or writing or composing or chatting over the internet or whatever, really. Mm, Or consider also a large language model, which can help you with some of these things, not and many others. Uh, so my first take here is that we can approximately classify the systems into, well, like, by their potency, by the breadth of the aims they can execute well. Some systems I will call unipotent, those that achieve approximately one thing well, and others pluripotent, those that achieve sufficiently many things that it's hard to pick one description of what they're good for. Mm, Now that's fairly hand waving. And honestly, about the power station, we could make it do much more things that output electric power if we considered it not on the level of description, where we consider it an immutable structure with some movable levers, but if we imagine that, well, it's a physical structure out of materials which we could move, demolish, restructure if we wanted to. This is kind of awkward for a description of a power station. This is necessary. This is a necessary level of description if we are in the business of building power stations. After all, they don't spawn naturally. They need to be constructed out of low-level components. But when we operate a power station, we don't really want to deal with the complexity of the real world. The power station is complex enough. So let's move on to fairly abstract description of fairly arbitrary system, which we, let's say, want to do things. So let's start with two, I don't know, spaces or sets. The first I will call a configuration space. That's the space of all the things we declare we can willfully change within a system. Throw a lever to the left or to the right, rewrite some code, move some movable blocks up or down, left or right, wherever they can be physically located, rearrange the furniture. And second, I will call the space of outcomes. What the system does in the real world when it is operating normally, not especially interfered with. So, for a hanger, the outcome space might be that it hangs and doesn't especially do anything else. For a power station, or rather, the outcome space, let me describe it like that. The outcome space for a power station includes the fact that normally a functional power station outputs power, but also there are other segments of the outcome space where the power station didn't exist and didn't output power. And we're really interested in the fact that we wanted it to output power, and so we configured it to output power. In any case, that's the first row of the diagram that we will use to describe the system as is, what is physically present, or what we are aware of. And now let's continue with also describing the system as it should be. So suppose we have a system, it operates somehow, it doesn't quite do what we want. We have imagined what we want it to do, and we think it might be able to do that. Now the question is, how do we make it do that? Probably there is some configuration we could find or achieve that would make it do exactly what we want. That is, when we just think about it, it's not necessarily known what is this configuration. So let's ask this question of the diagram. First of all, the question of how do we determine the desired configuration? Probably we want to take the desired outcome and compute in some way what kind of configurations would satisfy this outcome. Probably we could do that because we have a model which is represented by this horizontal arrow to the right of how outcomes follow from configurations. And we could try to compute this model in, backwards, if it is at all possible, and find from the outcome we desire what configurations would satisfy it. On the other hand, it might be that we don't already know the shape of the desired outcome. We might have some vague sense of what we would like that needs to be specified before we even can talk about configurations. Or we might not even have a good idea. Famously, what makes for a good life is not exactly a solved question. So the desired outcome of human life is not a target we could even start specifying. On the other hand, as I said, we would like to find the configuration that achieves what we want. Suppose even we know exactly what we want, but in practical system, configurations are pretty big objects. We could, for example, say that a configuration of a neural network is the entire gigabytes and gigabytes of its weights, and that's really quite a lot. Or we could say that a configuration of a software project includes, in particular, its entire code base, which is thousands to hundreds of thousands to more lines of code. And that's just not an object that we humans can manipulate in entirety, not an object we can hold in our head. If I consider a software project, and think, okay, this app is nice, it lacks this one feature, and if I try to compute the configuration that would make the system do what I want, the same application but with the new feature, I cannot say, okay, here is the 10,000 lines of code that do exactly the same app but with this new feature. I am not built to imagine objects of size of 10,000 lines of code. So instead, what I claim happens much more often is that from the desired outcome, or perhaps even from the small difference between the current outcome and the desired outcome, we can compute a small difference in configurations. Uh, like for a code base, look exactly in the code base where there is space to add this new feature such that it does not interfere with anything else, and add a small piece of code. Well, there's not exactly a slot in the code base, but I don't know, find or define a slot for this feature and put it right in. Mm, and thereby achieve a new configuration that is 99% the previous, but with a small change, but does achieve the outcome I want. Or we could ask more abstract questions, like epistemological ones. Uh, are we sure we know exactly the configuration of the system? How do we know that? Are we sure our observations do not lie to us? Are we sure our observations inform us correctly about the hidden states of the system? Or conversely, mm, are we sure we know what the system currently does? Do we measure what we measure? Do we measure what we wanted to know? Or ontological questions like what is the entire space or the type of configurations we care about. As I said, it is sometimes useful to think of a power station as a collection of, I don't know, physical objects, but that's really quite a lot of information. And often it is conversely more useful to think of it as an immutable object with a small, I don't know, interface surface that can be altered only in a limited number of ways. And likewise, for the space or the type of outcomes, it is, well, we could say that the space of outcomes is the entire physical world, but again, that's really too much information. We usually don't care about minute distinctions, like if the hanger is rotated half a degree uh, uh, to the left or to the right from our desired configuration, that doesn't really matter at all. And well, the choice of the, there is a ontology of the types of outcomes and configurations really is a trade-off between how much, I don't know, computational power we can throw at thinking of about the system and how much precision we need in the configuration, or how much control we want even in principle. Like consider, for example, well, to once again reiterate the example, if we want to build power stations, we cannot think about it as an immutable object. And if we want to operate, we don't care about its physical particulars. We would rather save time and memory. And really, and so on, because there are plenty more questions to be asked from this diagram, but I'm mostly out of time. To recap what I wanted, well, takes I wanted to give today is that I claim that configuration and outcome spaces are useful conceptual tools to think about fairly arbitrary systems. Second, that almost always changing the configuration is a fairly indirect process. Um, and third, most of the individual boxes or circles of the diagram are worth specifying when we try to reason about behavior of the system. And all right, there is a missing point that about the take that unipotency versus pluripotency is a useful distinction. Uh, Probably it can be phrased reasonably in the terms of the previous diagram, for example, about the breadth of the space of outcomes, but that's somewhat out of the scope of the current talk. Thank you. And now I yield the floor to your questions, objections, and comments, and everything else, really.
I guess there could be some systems where you can skip the config part and you just describe the outcome and hopefully it derives the config by itself.
Sorry, could you ask again?
So it's more like a comment or imagination. I guess that there are systems where you can skip the config part, at least explicitly, you only provide outcome and the config is then derived by the system internally.
Well, you could imagine systems like that. I would claim that, well, there is a secondary model I haven't really thought about very well, that we can think of some systems as, I don't know, modules. No, let me phrase it again. That approximately outcomes of some systems can be configurations for other systems. Like consider a system out of a programmable lathe and a specialist capable of programming. The specialist can be treated as a system that takes as a configuration a verbal description of the detail you need to make and can translate that into a more formal description for the automated lathe. And the lathe itself is, well, it takes a comparatively high-level description of, I don't know, a 3D model and translates that into low-level instructions of its actuators to move here and there at certain speeds. So I would say that there are systems where their configuration is in terms that are also used to describe outcomes we would like to see. So the specialist has natural language as its configuration language, their configuration language, and that's approximately the same language or the same ontology as we would describe the physical world. Yeah, that is, I think, my answer. I hope that answers.
Yeah, thank you. Yes. I'm wondering also about the systems where the outcome or config or root are some things which evolve and the system explicitly is open to changes in your desired outcome as the situation evolves. How does that relate to your framework? So simple example is that like room thermostat, you maybe want the room have higher temperature at night, lower temperature at night and higher temperature at day, and you don't specify that in advance for whatever reason, or another system like car, for example, you only, as you travel, you specify where you want to turn, but you don't specify that in advance.
Sir, to make sure I understood you, I specified the temperature the thermostat should target, but not what it should do to achieve that.
I wanted to introduce the aspect that the target is something which changes across time, and it's not expected that the future changes are provided in advance. Instead, we could provide the updates as the time goes, or new ideas come to our mind, or whatever. Maybe there is also some things I myself don't know in advance, and I provide new outcomes and configs as I learn about the current state of the world. So how does that relate to your scheme?
Mhm. Mm, hmm. Well, so far, there's basically no time anywhere in my model. So, well, it would. Well, the direct question is that so far my model doesn't interact with this question at all and is not especially helpful here. How I could extend it to accommodate time? Well, mm, obviously we could say that there are, I don't know, discrete timestamps, time steps where the system, I don't know, moves the, well, produces some final outcome on the next time step after being reconfigured, or produces some outcome based on the previous but informed by its new configuration. Well, okay, really, the answer here is this is not modeled and should be modeled, but I don't have any good choices to present here.
Maybe one perspective to look at this is the distinction between Turing machine and a real computer. Turing machine is not interactive, real computer is. And likewise, I expect AI systems to be interactive, not like Turing machine. I press the red button and then it just goes forever.
I would say that situational awareness is it's a part of really challenging ontology, like challenging outcome space. If we are referring to Anton's diagram, because it's the outcome space that includes our needs not formulated in our configuration space expectations of our perceptions. Like if we want a higher temperature during the night than during the day, not in these exact terms, but we want just to feel comfortable both during the day and during the night. That means we want the information of what it takes to make us feel comfortable somewhere outside our kind of explicit changes in whatever interface we have. We want something to deal with this information, to process it, to create protocols. And we want this thing to follow these protocols and not do random stuff with the temperature. But something, somewhere, somehow, among all the possible changes of temperature, they should be prioritized. This area of temperatures being high during the night, lower during the day, and kind of okay for humans. And different people prefer different temperatures. Like I like 16 during the day, and for most of people I know, it's too cold. Please make it warmer. So all of this is information. Somehow it should be transmitted into the system. And if we take, this is a kind of question that is kind of seems to be more naturally addressed using first-person perspective, using the idea of internal representation of the goal. Because I may say, if I succeed to create a system that wants to make me feel comfortable, and I make this system capable, then this optimizer will figure out what do I prefer, how should it change during the day and night, and etc. And that's where I put all of this complexity, all of this additional information that needed to be like pointed out. But it still kind of opens the room to how do I make a system that cares about what I want and just works in a configuration space where I exist and my preferences are kind of different and the concept of temperature exists. And this question is just a sort of killing questions. That's why mostly in our research agendas, I mean, mine and Anton's, we do not address directly this kind of stuff. We more think from what's visible from outside perspective, because that's seems to be a minimal level guarantee for like safety, survival, absence of economical crises or social crises, etc. But of course, preference question there, interesting, and reflexive intelligence are very interesting from moral point of view, from just curiosity, creating another kind to talk to communicate to as person to person. But it's a bit different from uh, figure out what way of making system with minimal effort uh, bring you up to survival, thriving humanity. That's probably what I'd say.
Thank you.
Are you sure that survival could be uh, uh, fully effectively specified just from the third person perspective? Because it's like if we assume that future AIs are going to be very intelligent, then possibly like for every kind of third person perspective definition characterization of survival, the AI could come up with some clever hack to make us like feel as if as dead in that state, but still outwardly looking as if we're surviving.
As for me, I think it's kind of interesting and open question. And personally, me, I would prefer to have an answer that let us survive and prosper in this exact world, build up this exact atoms with this exact people living inside, not kind of copies or whatever. Or, but that's kind of room for a discussion. Very much room for a discussion.
Oh, I see. So you mean that provided that things things like physical things stay uh like within a realm of like within some diff bounded difference to the status quo, then you could say confidently that the survival is yeah.
Kinda, yeah, but still, this statement is more about my preferences and hopes as a person, not my kind of best guesses as a researcher.
Hmm. Yeah, thank you. Yeah, it's nice point. Yeah, about this.
Could you please summarize once more what was the difference between the first person and third person perspectives?
In general, when I say I and me, that's a first person perspective. And I kind of apply a first person perspective to an AI system. If I don't know, put a research agenda, I want to create an AI system that values the same thing that I do. I want to create a first person and values for this person. And I want these values to be observable for that person. So it's a kind of first person perspective of making an AI. And it's probably like the maximum possible first person perspective you can do. Like relax this a bit and say that I want an AI to, I don't know, pursue something I think it's valuable. When I say I think it's valuable and address this as a goal to for the AI I'm making, that's kind of using a first person perspective. A third person is more like math-ish style of looking at things, closer to like inverse reinforcement learning. When I coded something, I trained something, and I want now to know what it ends up causing in the real world. If I make a self-driving car, I want to know what kind of road choosing algorithm it ends up with, etc. I don't ask what it prioritize. I don't ask, is there a like common one internally represented goal it tries to achieve. I just ask, what is the decision-making procedure I can observe and prescribe looking at its behavior.
Okay, thank you.
We have 2 minutes, I think, left till the next time slot.
Is there any email address or something I can contact you later?
Yep, sure. I'll be glad to. That's mine. You can mail me, and you can find me on Slack. Mostly I save it as Slacks.
Thank you. And I also understood that you have some less wrong post. Can you please share link to that as well?
No, it was the one I recommended. It's not mine. I wish
okay.
it would, but I'll send you the link. That's the one.